Good morning and welcome to math class. Today is Wednesday, April 29th, and today we're going to be working in lesson 7.5. If you've noticed, we skipped over 7.4. 7.5 is a little bit different than what we're used to, and it's going to require some work out of you at home. Before we get started with the math message, you need to go into the module under the tech information where it says Math Masters page. That page has a lot of triangles all over it. You need to print that page out and cut out those triangles. And then I'd like for you to cut the triangles out and sort them any way that you want. So it's going to take you a few minutes to do that. So pause the video, get them all cut out, and then sort them any way you want. Once you've done this, then restart the video and we will continue. The small marks on the sides of the triangles are called tick marks or hash marks. If two sides are the same length, they have the same number of tick marks. Be sure that you understand that a side with two tick marks is not necessarily longer than a side with one tick mark. The number of marks is arbitrary. Some of the triangles have tick marks and some do not. The marks are not necessary when you can clearly see that the sides are not equal in length. So let's think about the different ways that you sorted your triangles. Maybe you put triangles with a right angle and triangles without a right angle. Or maybe you sorted them so that triangles with all sides the same length, triangles with two sides the same length, and triangles with all three sides a different length. Let's talk about what an attribute or property is. An attribute or property is a quality or trait belonging to an object or an individual. Think about some of your own attributes or properties. For example, you have your own hair color, eye color, height, shoe size. Those are all attributes. So now identify the attributes that you use to sort your triangles. Maybe you used side length, or maybe you used angle sides. When you sort objects, you can sort them into groups that overlap or groups that do not. Look at the way you sorted your triangles. Think about some of the sorts that have groups that do not overlap. Maybe you have triangles with a right angle and triangles without a right angle. Triangles with all sides the same length and triangles without all sides the same length. Most of these would be non-overlapping groups, and that's how most of you probably did your sorts. Did anyone do their sort with a group that overlaps? An example of that would be triangles with two sides the same length and triangles with a right angle. Some triangles, those with two sides the same length and a right triangle, would fit in both groups. How about another example of an overlapping sort? Maybe you did triangles with a right angle and triangles with three sides of different lengths. So today we're going to explore a new way to classify triangles into overlapping groups. Alright, so I'm going to give you an example, and this would be much more fun to do if we were actually at school in our classroom, but I think that you can at least think about it and think how this would work. So, if I had all of you stand on one side of the room, and then I called out all the students who have at least one sibling to walk to the center of the room. Most of you would walk to the room because most of you have a brother or sister. So the group in the middle has only students who have siblings. The group that's still on the side by the wall will be students who have no siblings at all. Then if I said students who have a brother walk to the other side of the room. Now we have groups of students that get more specific as we move from one side of the room to another. Any student in our class could stand in the first group. Some, but not all of the students in our class have a sibling, so only those students can stand in the middle group. Similarly, some, but not all of the students who have a sibling have a brother, so only those students that have both attributes can stand in the last group. How would you possibly draw this if we did this activity in our classroom? Maybe you would have labeled it like this. You would have started with this side of the room that has the students in our class, so that's everybody. I'm just going to put studs for short. Then in the middle we had studs or students with a sibling. So they have a brother or sister. This is really hard to write small with this stylet. And then finally, on this side of the room, I'm going to write it down here since I'm running out of room, we would have students who have, or in my class, who have a sibling that is a brother. Or maybe you would have thought to draw a Venn diagram. If you remember a Venn diagram, we draw a big circle, and you could say on the outside of that circle are all of the students in my class. Okay, then I'm going to make a smaller circle, and this is students in my class with a sibling. Students with sibling. And then in the smallest circle, I have just the students in my class who have a sibling that is a brother. That would be another way to represent relationships like this, is to draw a Venn diagram. The other way we could do it is to create a hierarchy. In a hierarchy, we are going to demonstrate our relationships like this. The most general group goes at the top of the hierarchy, and the groups get more specific as you move down. So which group should go at the top? Well, that would be the students in my class. So that's going to be the top. And then what would come next? Students in my class who have a sibling. Students with a sibling. And then I would move down even further to the bottom, and this will be students with a sibling who is a brother. Students with sibling that is a brother. So this is what our finished hierarchy looks like. So this is a hierarchy for students in my class, and it is a category of students. All students in the first category share an attribute. They are all members of my class. Okay? Then we added the attribute of having a sibling, and so those students walked to the center of the room. That's this group here. So they formed a subcategory of students. They're still members of this larger category because they're still in my class, but they also have an additional attribute that they have a sibling. So what other subcategory is on the hierarchy? The students in my class who have a sibling that is a brother. So they have a sibling who is a brother, and they are students in my class. The group at the bottom of the hierarchy is a subcategory of the group in the middle, and also a subcategory of the group at the top. Any group that has all the attributes of a category and one or more additional attributes is a subcategory of that category. So what are some other categories and subcategories of students, and how could we organize those into different categories? We could do a hierarchy of students in my class, and then we could have said students who have pets. So they're still students in my class, but they have pets. So we'll say students with pets. Then another subcategory is students in my class who have pets that have a dog. So this bottom group would be a subcategory of this middle group, who's also a subcategory of the students in my class. Another one that we could do are students in my class. And a subcategory of that would be students in my class who play a sport. And then a subcategory of that could be students in my class that play a sport who play baseball. So that will be the bottom category in our hierarchy, and that's going to be the smallest group compared to all three groups. Okay, now you're going to use your triangle cards to create a hierarchy of triangles. There is a math journal page in your module that has this on it. And before you start this hierarchy, I want you to take two cards, any two cards in your stack, and just set those aside for later in this activity. So just like I did the students in my class was the top category in the hierarchy of students, your top category is going to be triangles. So you're going to write triangles at the top. So this is that math journal page. You're going to write triangles right under where it says triangle hierarchy. And you could put all of your triangles there. So what properties do all triangles share? All triangles have three sides and they all have three angles. So three sides and they all have three angles. Okay, create a subcategory of triangles and see what that looks like, kind of like the ones with the students that had a sibling. There are attributes but some of these triangles have, but not all of them. For example, you could do triangles that have at least two sides that are of equal length. What do we call this attribute of two sides of equal length? We call those isosceles triangles. So maybe you're going to have your next category be isosceles triangles. I'll spell that out here for you. Isosceles triangles. So that's your next category after you did triangles. Okay? Now, so you're going to have a big long arrow from triangles down to isosceles triangles. Now, find all of the isosceles triangles in your triangle cards and put them down in that next group next to the isosceles triangle subcategory. Remember, they're to have at least two sides equal in length. They can also have more than two sides equal in length to fit this. Could we have left these cards in the triangle category that had more than two sides equal of length? Yes, we could have. They all have three sides and they have three angles, but we move these particular triangles down to the isosceles triangle subcategory because they have at least two sides of equal length. So this would be yes, we could have left them there. Now let's create another subcategory to add to the hierarchy. Look at your isosceles triangles. Do you see a property that some, but not all of the isosceles triangles have? It could be that some isosceles triangles have all three sides the same length. What do we call triangles with all three sides the same length? We call those equilateral triangles. We'll write that on here for you as well so you know how to spell it. Equilateral triangles. So you're going to add that to the bottom of your hierarchy. You're going to draw an arrow down to it and put that at the bottom. And you're going to find all of your isosceles triangles that are also equilateral triangles and move those cards down to the equilateral triangle subcategory. Could we have left those cards in the triangles category? Yes. Could we have left them in the isosceles triangle subcategory? Yes. They're all still triangles and they're all still isosceles triangles. They just have an extra property. They have all three sides as equal length. So they are considered equilateral triangles. All right, now find the two cards that you set aside at the beginning of the activity. Now we're going to try to classify the triangles on the cards into the hierarchy one at a time. First of all, ask yourself, is the shape on the card a triangle? Yes. How do you know? Because it has three sides and three angles. Can you put the shape in the top category? Yes, you definitely can. So you could set that card in the top category. Now, is the triangle on the card an isosceles triangle? How do you know? Because isosceles triangles have at least two sides equal in length. If the card does not show an isosceles triangle, you leave it in the triangles category at the top and you're done classifying that triangle. If it shows an isosceles triangle, you should move it down to the isosceles triangle category. Is the triangle on the card an equilateral triangle? How do you know? Equilateral triangles have all three sides equal in length. If the card shows an equilateral triangle, you should move it down to be next to the equilateral triangles subcategory. If not, you will leave it in the isosceles triangles category. Once you've completed that with the first card, then you need to take the second card and go through the same process with it and figure out where that second card goes in the hierarchy. So now I would like for you to go ahead and try to finish the second page of the math journal pages. There are 5 questions on that page. Once you've finished it, I have placed the answer key. It says Math Journal Answer Key in your module, and you can check that and make sure that you have all the correct answers. If you have questions or you don't understand how they got some of those answers, be sure and send me a message on Canvas. And then you will have Math Boxes 7-5 to complete and HomeLink 7-5 as well for your work for today. I hope that you have a great day, and I will see you tomorrow.